Great. So yeah, as Matt said, I am Mayur Thakur. I run analytics for compliance at Goldman Sachs, which is right somewhere there. And it's great to be here. I didn't actually know there will be so many people. I met Matt at a similar thing event last week, actually. So what I'm going to talk about is how we do surveillance at a large bank like Goldman Sachs. And in particular, for this crowd, what I'm going to describe is some aspects of the surveillance platform. And before I begin, let me just say what that means, because or give you a little bit of context. The financial crisis, essentially, since the financial crisis, two things have changed. One is the focus of the regulators. They're asking many more deep questions. There's many more regulations, so on and so forth. The other thing that has changed is just the amount of data that we are required to look at. Right? So keep just those two things in mind as we go through these slides. And I hope what you get out of this is some understanding of how compliance is just much more data driven, to borrow a phrase from the event, at banks like Goldman Sachs. Okay, so here's the question. What do the following problems have in common? And I will describe these 4 problems in the next 4 slides. And the first problem is temporal joins, or joining huge databases using time, right? I'll come to that. The other one is synonyms and spelling corrections. You would probably all have seen it unless you are a perfect speller. You make mistakes when you enter things in Google. Okay. The third one is surprising relationships in social networks, which is think of your Facebook network and imagine actually let's take me for example, right? I used to work at Google. Think of my LinkedIn network. Actually, I'm not on Facebook, but so think of my LinkedIn network, and they're kind of two distinct sets of people: Google people and Goldman people, essentially. And it will be surprising if anyone, like, if there's the connection between those two guys, those two sets. Okay, so that's how do you mine that automatically, right? So I'm describing like 4 problems to you, and what I want you to think of is what do these things have in common? Okay. And the fourth one is detecting unusual spikes in time series. So, Bitcoin is popular these days, right? So think of the price of Bitcoin. What are unusual spikes? I guess you'll say everything is unusual or everything is usual. But think of, time series like that, right? What are periods of unusual activity in a given time series? Okay? So I'm describing computer science problems to you. And what I want to ask is what is common to them. So again, this a little bit more detail is like, so imagine you have 2 databases. So the cylinders are the 2 databases. And what I want to do, so the first one has 100 million rows. The second one has about 1 billion rows. And what I want to do is this whole little triangle here, I want to join in this case with 3 of them because they occur very close together, right? So that there's some time associated with this guy, and there's some time associated with this guy, and they happen to be very close to each other, right? So when you join them, you should probably get 100 million rows, and each row will have each like blue triangle will have all the rows from the 1 billion row from a bigger data set that is close in time to all of them. Okay, that's what I mean by a temporal join. So that's problem number 1. Problem number 2 is synonyms and spell correct. So I typed something in a search engine, which I'm not showing everything from, and I mistyped machine learning, and it spell corrected, to machine learning, the right spelling. This should be easy. The third one is the one I was talking about, is think of this as my Google network, think of this as my Goldman network, and it's surprising that there's some people here that actually know each other. It's just like, I can tell you for a fact, right? Just like, or you look at this, and you can say, yeah, like, why is that? Because normally, people in this side of the slide talk to only people in this slide. People on this side of the slide only talk to people on this side, right? So why is this this particular individual talking to that individual. So I'm talking about computer science problems that you want to detect automatically, you want to solve at a large scale. So imagine this was the actual Facebook graph. Or in our case, slightly smaller than the Facebook graph, but still about 100 million nodes and about 1 billion edges. How do you do that? Okay? And the fourth one is the spike detection, where there is some time series and you see an unusual spike, or in this case a valley, okay? And you want to detect those periods, so then you can then investigate. So the question I have for you is, what is common, right? What's common to all these things? Anyone? Yeah, that's kind of obvious, right? So what I can tell you is that all these things are actual systems we have developed, right? I'm not claiming that we have developed the original algorithm for these, but we are using all of these in production for surveillance in some form at Goldman in my team, right? What is a surveillance? Let me just describe very, very briefly. A surveillance is a piece of code, right? It's a model, roughly speaking, implemented in a piece of code that's running and looking at a lot of data and outputting a few things, right? So imagine an insider trading surveillance, which will look at all trades that Goldman or its employees or its clients do, and it will flag a few things that the model thinks is suspicious, right? Similarly, a spoofing surveillance, and for those of you who don't know what spoofing is, it's a market manipulation technique. It's bad, don't do it. It's not right. Where market participants try to move the market in their favor by showing interest in the other side, right? So let's say you want to buy. You put orders on the sell side. That creates a market pressure, and under certain circumstances, the market moves in your direction, and then you cancel your sell orders, and you can profit, for example. So anyway, those are examples of surveillances, right? So all the problems I'm describing to you, and some of them will be obvious to you, but I'll go through them and tell you how these are used in surveillances. Okay? So for example, but I just want to make sure that people understand what a surveillance is. Again, think of a surveillance very simply as a black box that takes in a huge amount of data. So let's say it takes in, let's say we're building a spoofing surveillance. So it will take in maybe 500 million orders and let's say 20 million executions, which are actual trades that are executed. It may take in like 5 billion market data events in a day, and then output maybe like 200 trades, which say, okay, these things look suspicious, and for this reason. Okay? I'm not going to go into that level of detail in the interest of time, but have that in mind. Okay, so why do I need this? I described it in a very abstract way. Why do I need this? Well, I'll say that this one is, for example, all the orders, right? Or let's assume that these are all the orders. What I want to find, actually, let's assume these are all executions, which is trades that someone put in through Goldman, whether it's a trader or a client. And what we want to find is what was the market at that time, around that time, right? Let's say you put in a trade for Google at you being either a client or a trader at Goldman. And what you want to find is around that time, maybe a few seconds before, a few seconds after, what was the market doing? So why do I want to see that? Because I want to see changes in the market as a result of your execution. Because if I do, what you're trying to do is, if you're trying to move the market, I do want to see that, right? So a problem about manipulating the market comes down to a problem about kind of joining databases, really, right? But if you take 100 million and try to do brute force and in 1 billion, so this has what, 10 to the 8? This is 10 to the 9. 10 to the 8 times 10 to the 9 is a large number, right? So we can do that. We have to do that, in fact, in a smarter way. So that's an example of kind of a database, large, big data problem helping compliance develop surveillances. Next one, synonyms and spell correct. So this is a screenshot of an actual search engine that we have developed, and you have to believe me that there is more stuff here that I cannot show you. But instead of web documents being the set of documents, think of all the emails, all the chats, all the Bloomberg messages that come or go out of Goldman as being the data behind it, right? So like 2 to 3 billion documents billion documents behind it, and we call it ecom, right? So ecom is emails or chats or IM, so on and so forth, right? And obviously I did a query that that is kind of benign, right? But the kind of things you're looking for here, the uses of this is lots of things, right? You want to figure out who talked to whom, on what subject, blah, 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 right? All these things you can enter the query and within sub-second get results where it's actually going through billions of documents and finding the relevant results. Results being in this case emails or chats or IMs and so on and so forth, okay? Next one, pattern detection in social networks. I talked about insider trading, which is kind of the prototypical example of a surveillance, right? So what you want to find out is, was there information leakage? So I don't show a good graphic here, but think of, normally speaking, there are all different types of information barriers at banks, right? So think of this set as being a group, let's say, on the trading side, that normally does not talk, right, to people it's not banned, but they normally should not be talking to people on the private side, for example, right? And so you want to automatically detect those things, right? When I present it this way, it's very easy, but imagine now there are like 60 million nodes, which we actually have a graph, right, that has about 60 million nodes, and which has all the employees, all the clients, all the entities we deal with, and it's not even complete yet, right? And it has about 1 billion interactions, so 1 billion relationships that we know of, right? So not quite Facebook scale, but not small either. So what you want to find is, I say, interesting communications or suspicious communications kind of automatically. Finally, this is a time series of a market, like let's say a stock. And what you want to do is there are lots of events, there are lots of orders, there are lots of executions. What we really want to do is focus on interesting periods of activity. And so for that, we want to find interesting periods of activity, because then we can say, what were the clients doing? What was the traders doing? So on and so forth, right? And that's the reason, okay? So in summary, what I showed you, hopefully, is that there are interesting, seemingly unrelated problems to compliance that are very, very, very interesting to compliance, which we use in production, most of them, to develop surveillances, right? So the way we think of, I joined Goldman about 3 years ago, and the way we think of a surveillance platform is, it's kind of depicted in the slide, right? And I talked to you a little bit about it. So let me just summarize the slide. And essentially, we think of the data that we have. So we have massive amounts of data. We have about 1 billion pieces of e-com in a year. We have about hundreds of millions of orders in a single day, billions of market data events in a single day. We have to process all of that, and then on top of that, we have to join, and then we can run these surveillances that we have, right? But this is the simplifying slide, and I'm basically saying the way we think of it is we think of it as data types. Right? There's kind of 3 basic data types. One is text, what you will call unstructured data. So that's the prototypical example we have, and the most important for us is emails and chats, essentially. Then the other one is relationships, or what we model as graph. Okay, and the third one is lots of numbers, right? So lots of strings, lots of relationships, and lots of numbers. And then there are different techniques we use. I showed you a little bit. I try to give you a flavor of a little bit. But notice I did not quite use buzzwords like NLP or deep learning or data science or machine learning, which I could very well have used, but I don't think it's that useful. Okay, and so that's why I put it on the slide. And I want to stop here. I can go on for a little bit. I just want to stop here. Is that it, or do I come and sit there? Or
yeah.
Questions?
Thank you very much.
I'm wired up, man.
Yes.
Yeah.
Do you want to talk a little bit maybe about the type of technologies and stack? What powers all this?
Correct.
And then we'll open up to
Sure. So if you think about what I described, we are in the business of building surveillances, right? All the data munging and all that stuff we do, ultimately the business goal is to build surveillances so we can, surveil for reputational risk, right? So what we think of as, risks to the firm because, of things that we shouldn't be doing, essentially, right? We being, either the firm or the clients, right? So if you think about that, that's what is typically is a detection. It's not prevention, right? I mean, there's a little bit of prevention, but most of it is detection. Okay, so the reason I mentioned that is because you asked about the technical stack, and really what we do is our focus is get a whole bunch of data and then apply these techniques. We can afford to live with T+1, right? So if, for example, a trade happened today and we run our algorithms tomorrow, that's okay because that's what a surveillance is, right? As a result, most of these things that I presented, except the search, obviously search has to be real time, right? If you enter search query today in Google and you get a result tomorrow, it's not really good. So other than search, everything I described is batch processing. We use standard Hadoop, we use MapReduce, but we have optimized quite a bit on based on our data, our needs, so on and so forth, right? So the technical stack is pretty simple, but it's a kind of a big data problem, right? So like just borrowing a buzzword, right?
And it's interesting and fairly well documented that Goldman Sachs is actually using a lot of open source.
Yeah, sure. Sure. So what I'm talking about is about my world, right? I'm not talking about Goldman Sachs in general. Goldman is pretty big, right? So there's all sorts of different technologies people use, and I'm not really equipped to talk about everything because I don't even know about everything, essentially, right? But I was talking about the specific compliance analytics use case, which is also pretty broad. Compliance is, our users, for example, as I mentioned in the process, the alerts that we produce, so from the 100 million trades, so let's say if we have 100 alerts, 100 trades, someone is going to look at each of them, right? So those are actual, compliance officers who look at them. And so we have enough users, but it's kind of restricted to compliance. That's a good question. How do you measure success? Yeah, how do you measure the thing that did not happen, for example, right? Now, I won't give you all the answer, but I'll say on the technical level, each of the models that we develop, right? What we are not looking for, example, what we're not looking for is absolutely, okay, this is something that is an absolute, if you think of alerts, right? Some things could be benign. Some things could result in, a supervisor talking to an employee or we talking to the client, blah, 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 all the way up to, there is a criminal investigation, right? So we're not looking at the last one. So what we do is every single alert that we produce is looked by some human. So we ask for their labels. We say, was this worth your time is really what we're asking. Do you want to see such a thing again? Or it was so, it was so stupid that, why, if you question, why did you even show me? If it took you 1 second to close it, then it's bad. Otherwise, it's okay, it's interesting. So we ask that question, do you want to see this alert again? Kind of regardless of the outcome, right? Because it really is a needle in a haystack problem. So we can't think of the last, the most egregious violation. We don't think of it that way. So once you have that, so we have labeled data that way, not a lot, but a little bit, then we can measure precision, recall, that kind of thing. Oh, sorry, go on.
Hi, just out of curiosity, has your surveillance ever caught up an AI
example, there might be some high-frequency trader using machine learning, and machine learning has stumbled upon spoofing as a way to make money, but it doesn't know that it's money.
I'm sorry, I cannot go. I'm sorry, I cannot go into the specifics of what we have caught, what we have not caught. Right? That's like, you're not going to get me to say that. Sorry.
Good question, though.
I mean, it's a good question. Yes.
Maybe one more here quickly.
I actually saw a presentation on this subject maybe 2 or 3 years ago. The problem actually hasn't changed much in the kinds of techniques that are being applied. So I'm interested in what have you seen change? Is it simply just scaling more and making it go better? Or have there been any kind of step function improvements in capabilities over the past couple of years? And related to that, where do you see the big opportunity looking forward?
I don't know if you saw my talk, but if you did, sorry about that. So I think what we did in the last 3 years is first we had an idea that, I mean, this is the vision. This is where we want to go. But now things are in production. We know what to do. We our kind of technique has been validated, so on and so forth, right? If you think of the opportunities of where you can do, essentially like as someone asked, right? We really think of, are these producing the right kind of alerts? These are producing results that we expect them to produce, right? So that's the opportunity. In terms of techniques, right? I mean, we are kind of technique agnostic. I've shown you a whole bunch of techniques that we use, but we really drive it from the kind of, is it producing the right kind of alerts? We do heavily, I didn't go into that, we do heavily use things like intuition of people who are on the front line. We use things like, what are the regulators asking to drive, the techniques and the problems we focus on. Did I go over time? I'm sorry about that.
No, this is great. No, we were just trying to work on a smooth transition.
I see. Yeah.
So while we set up George, maybe time for one last one.
There's some question here, I think. Yeah. Yeah. So again, this is a good question, right? So as I was describing, right, in order to measure false positive, you need to know what ideal is, and our ideal, generally speaking, comes from experts in some sense, right? So the other compliance officers, they may not know so much about computer science. They know a lot about the business. So they will produce, some basic alerts. They will label them, so on and so forth, right? And we generally hold ourselves to, it's a very recall-driven, if people know what that means, but I'll describe quickly what it means. It's like we want to catch a lot of things that we should be catching, like 95% of that, right? The more the better, but that's what we hold ourselves to. And then on the precision front, which is, if I'm going to show you something, 1 out of 5, like 20% of them should be interesting. That's you have to trust me that that's a high bar. Right? If some of you have worked in this, because really small needle in a big haystack, right? So 20% precision, 95% recall. That's what we try to achieve. Sometimes we do, sometimes we don't.
Thank you so much.
Yeah.